The first automated flashing red light railroad crossing signal appeared around 1913. The flashing lights mimicked the motion of a lantern being swung back and forth. The X-shaped crossbuck sign, in use by the early 1900s, was inspired by the skull and crossbones, a symbol for danger. Before automated signals became common, railroad crossings were protected by railroad employees. A person was stationed at the crossing and manually activated a signal or gate. A small booth protected the signal person from inclement weather. The earliest type of railroad crossing signal is called the wigwag signal. This was named for the way they swing back and forth when activated. This first appeared around 1913. Their waving action simulated the motion of a lantern being swung back and forth by a person. These signals were driven by electromagnets that alternately pulled and released the pendulum. The modern railroad crossing features both visible and audible warning signals that a train is coming, such as red lights flashing, a mechanical electronic bell sounding, and usually a gate dropping. The basic railroad signal consists of flashing red lights, a crossbuck, and an alarm attached to a mast. At most railroad crossings, the signals will activate about 30 seconds before the train arrives. There are sensors measuring speed so that the crossing knows when to activate. The slower the train is, the longer the delay, and the faster the train is, the earlier the crossing activates. Modern railroad crossing signals work as follows. As the train passes the first detector circuit, it changes the impedance of a coded circuit in the track, sending a signal to the signal box that a train is approaching. Automatic signals use electrical relays in the track, with low voltage current running through the train's wheels and axles. Warnings include visual and audible, such as flashing red lights, a bell sound, and gates dropping across the track. Modern railroads are replacing trackside signaling equipment with modern in-train computer displays and control centers. The future of railway signaling belongs inside the train.